Now, dear students, class even 11 physics practical we have, and last time I have given the some PPTs related to the Screwguage. So I hope you have made the work inside your practical notebook regarding to that one. And I am just asking that you must make the pasting of the readings, and I'll show you the method that how can you use the Screwguage. So basically you must see it that this is the instrument that is called the screw gauge in front of you, and what are the parts and what are the scales it has. So I am just showing you that these are the jaws we have, and in these jaws we can attach a wire or the rod is there for which we want to make the calculation of the its diameter. Okay, so this is the one of the object I am just showing that by this method I can attach the screw or the kind of a rod between the jaws of a screw gauge. Okay, so these are the jaws we have. Now what are the types of the scales we have? So I am just releasing it further. Now what are the types of the scale we have? Now we should make the comparison of the vernier calipers here also. Vernier calipers having the two scales. First is the linear scale, that is called the main scale, and the another one is scale that is called the vernier scale is there. Okay, so through which we are just making the conclusion of the vernier constant. So same how this is the kind of the rotating screw we have. So we can make the movement of a circular scale on a main scale. On the circular scale I can show you that there are the number of the 100 divisions. Okay, total there are the number of the 100 divisions are there. Now this is the 0 division is there, and along which I can see if I am just rotating, so it comes in the manner 10, 20, 30, 40, 50, 60, 70, 80, 90, and then it's coming to the 0. That so we can assume that there are the 100 divisions we have, and this is the kind of the main scale we have. And this main scale having the measurement that is written on the screw gauge portion, metallic portion, that 25 into 1 mm. So each division is having the length that is called the 1 mm, and total there are the 25 divisions are there, so it makes the measurement of a 25 mm length is there. Okay, so how can we proceed the reading? So one of the need we have to discuss the meaning of the least count we have. So I have given already the formula to you. Further I am repeating it. The least count is simply the ratio of the or pitch is to be divided by number of division on a circular scale. So how many divisions we have on the circular scale? That these are the hundreds we have. Now what is the basic meaning we have? That is called the pitch. So what actually the pitch? Pitch is a simply the linear scale which is covered by a circular portion, as we are just giving the rotation of the rotation to the screw. Okay, तो इसको मैं कैसे एलाबोरेट कर सकता हूँ, कैसे इसको मैं कर सकता हूँ? आई एम जस्ट मेकिंग द coinciding of the zero to the main scale. Okay, at the one of the reading मैं यहाँ इसको सेट करता हूँ, अपने ज़ीरो को 20 mm के ऊपर सेट करता हूँ, and then I am just making the rotation to the screw either in a clockwise direction or in a anti-clockwise direction. Okay, तो अगर मैं clockwise direction में देता हूँ तो ये जो circular scale है ये linear scale पे आगे की तरफ बढ़ता है. I have made it on the 20, so I am just making or giving the rotation to it. सो ये 20 से 15 की तरफ मूव करना शुरू करेगा, एंड पर्टिकुलर गिवन रोटेशन में ये कितनी डिस्टेंस कवर आउट करेगा उसको ही हम पिच बोलते हैं. तो सपोज आई एम जस्ट गिविंग द 5 रोटेशन, 5 आई एम जस्ट मेकिंग द क्लॉकवाइज रोटेशन, it comes about on the 19, then further one rotation I have completed. Now the second rotation which I am just completing here, this comes on a 18. Now further I am just giving the third rotation, so it comes on a 17. Now fourth rotation I am just giving to it, so it comes on a 16, and in the last only 5 rotation I am just give I want to give. Now in the last rotation it comes about the 15. Okay, So here we can make the meaning that as we are just giving the 5 rotation, so it covers the 5 mm distance, so that is called the pitch is there. So we can write the basic meaning of the pitch in the formula. So what actually the pitch? So 5 mm distance covered by a circular scale on the main scale is when we are just giving the 5 rotation. So what is the meaning of the pitch we have? That is called the 1 mm is there. So here we can write the 1 mm and we are just dividing it, so it comes about that 0.01 mm is there. So somehow we have to be convert that one into the centimeter, so I can approach it that 0.001 centimeter in the part of it. Okay, so either you want to change it, it's okay, or either you are just going with the concept of the mm is there, because we have the main scale in the part of the mm, so we can easily go through it. Okay, so this is the all about the pitch is there. Now we have the concept of the negative zero error. So whenever I am just completing closing the jaws, so whenever the jaws are meeting to each other, so we should pay the attention that zero of the scale should be zero of the rotational scale should be considered with the coincide with the zero of the main scale is there. So there is a no kind of the error is there. Suppose the zero is leaving the main scale and moving ahead of it, so it is called the negative or the backlash error is there. So definitely I am just getting the error is there inside the screw gauge. So I am just I am just closing the completely jaws. So I am just saying I am just watching it that there is a 90 scale, that is 90 divisions that comes on a main scales. Okay, and the zero is moving ahead of it. Okay, so near about the 10 division error is coming in this portion. Okay, so this is called the negative zero error we have. And how can we make the resolution of this zero error of 10 division? I'll just making it conversion with the multiplication of the least count is there. So we are just getting the 10 division backlash error is there, or the negative zero error. So we should make the plus in the on the final answer, okay, of the diameter. So 10 into 0.01 mm, that makes the 0.1 mm is there. Okay, so this is the one of the zero error portion is there. If it is not, so you there is a no kind of the adding or the subtraction in the main diameter portions. Okay, so here we have got, so I am just writing it. Now one of the object or the rod which I have taken, and for it I want to make the measurement of the diameter is there. So I am just fixing it inside the jaws and making a final that mean twisting by this screw. Okay, so this is the complete fixing of this portions of the screw gauge. Okay, now I have to be choose the two reading. First is the linear scale reading or the main scale reading. So I am just asking that how many sections I have to be here, that coinciding of a circular scale with the main scale is there. So uh, 5, 10, 15, and then after 3 division we have. So it shows that the main scale reading is coming in the part of the 18, and 18 what mm is there. Okay, so this is the simplest that in observation we have noted down, that is linear scale reading. Now I am just talking the circular scale, so I can easily see it. The 65 sorry 64 division is coinciding with the main scale. Okay, so in the out of the 64 division is making the coinciding on the main scale. So this is the circular scale reading we have, and definitely least count we have, so we can make the easily calculation. So here I have made the first reading calculation of the first reading. 80 mm is the main scale reading, 64 division which coincide with the main scale, multiplied it by the least count 0.01 mm, and the diameter calculation we can make it, that is called the 18.64 mm is there. So same how I am just repeating these observations in the same manner, and now I am just making the repetition of this measurement at the different place. Okay, so I am just dislocating the jaw this object between the jaws of a screw gauge. Now further I am just getting the main scale reading, same how it is coming. The 18 is there, but the circular scale reading is coming near about 75 is there. So this is the second reading we have, and the similar manner in the similar manner I have to be taken the another reading also. Now we are just moving towards the next section. That mean we are just displacing this one rod. Why we are just doing this one? Because the rod can have the different shapes. Okay, so we are just finding the identical diameter should be there. So I am just completely fixing this jaws around the given rod is there. So definitely the surface is very rigid, so the main scale reading will be same as per the previous portion. So it comes about the 18 is there, and the circular scale reading which coincide with the main scale, that is called the 50 is there. So this is the simplest method to make the measurement of the reading is there. Now, dear students, I have taken another readings with the variation in the circular scale reading, because the surface of a rod is a very rigid. So the linear scale reading will not change. Only the meaning of the circular scale reading will change. So I have mentioned all the portions of the diameters of the rod are there. Now I have to be make the calculation, and this calculation you should make on a white page. Okay. So I am just making the calculation of it, and the simply I am just getting the mean of these diameter. Okay. Now I have made the simple calculation of all the diameter. That mean diameter comes about the 18.6 mm is there. Okay. Now we have the mean diameter, and we have to be include the negative zero error in it. Okay. So 18.60 plus of what was the portion of the negative zero error we have? uh, there are the total divisions, that was the that mean 10 into 0.01 mm was there, because whole parameter should be in the part of the mm is there. Okay, so whenever we are just solving it, so we are just making the correction of the negative zero error with the total reading. So by the mean of the correction, it comes that 18.61 mm is the diameter we have. Okay. Now one of the another thing we have required as per the formula, that is the length of the rod we have. So this length we will measure by the help of the scale is there. So easily I am just making the length of this scale. So it comes near about I'm just showing directly. You can use your scale, whatever the scale you have. So here it makes the conclusion of the length of the rod is there, 13.8 is there. Okay, so I can show you, or whatever, that's a simply method we have. Okay, and we have to be measure the length three times, because always we are just making the less error portion is there. Okay. Now we have the general formula of the volume is there. V is equal to pi r square. H is there, or the L is there. So we have the basic that mean diameter. So we will convert this one into the part of the diameter is there. D is equal to that mean 2r, r is equal to d by 2. So I am just making the little bit changing here. Okay, and that d square by that mean 4 is there. So one should you must keep also inside your mind, one of the diameter is available in the part of the mm is there. So we will make the conversion, because the length in the centimeter, so we should keep all the parameter in the same unit system. So either you are just converting this one parameter in the mm or in the centimeter is there whole. Okay, so it's a very much easier to be make the conversion in the part of the centimeter is there. So I am just making the conversion of the diameter in the part of a centimeter and making the calculation for it. So here I am just getting the answer that 37.55 centimeter cube is there. So by the help of the Screwguage, we are first assessing the meaning of a diameter of a given rod, and then after by the help of a diameter we can make the assessment of the volume of the given rod. So you must do all the observations with the following calculations inside your record and complete it before the time. Okay, thank you.